Here's the last section of Unit 5, Lesson 3, Dimes and Quarters. In this little section, we're going to be talking more about independent and dependent variables, only this time we're going to be using some money. So when we talk about this piece, what we need to understand is how can I use a function efficiently? What you'll notice here is that Jada has some dimes and some quarters and had a total value of $12.50. The relationship between the number of dimes D and the number of quarters Q can be expressed by the equation 1/10 of D plus 2,500 Q is equal to 12 and 5/10. This is really nice that they gave us the equation because this actually helps us to be much more efficient. And we can go ahead and just kind of move forward with this by using substitution. What we know is that Jada has 4 quarters. So how many dimes would she have? We can simply use substitution to start plugging in numbers. 1/10 per dime plus 25 cents per quarter. And we know that there's 4 quarters this time, which is equal to $12.50 or 12 and 5/10. This would give us 1/10 of D plus 1 is equal to 12 and 5/10. As I subtract my 1, that's going to give me 1/10 times D is equal to 11 and 5/10. And then when I divide by 1/10, D will give me 115 dimes. So when Jada has 4 quarters, she has 115 dimes. That would give me an ordered pair that would look something like this: 4 quarters. Actually, I'm going to hold off on that part because there's some discussion that goes with that. So what happens if we change the number and we give Jada 10 quarters? Well, 1/10 per dime again, 25 cents per quarter for 10 quarters is equal to 12 and 5/10, meaning that she has $2.50 in quarters. And if we take that away, we're left with a whole bunch of dimes that equal out to $10, which means that the number of dimes that she has is going to be equal to 100 dimes. And there's $10. So it's kind of a simple way to be able to figure this out. If we know the number of quarters that she has, then we can find out the number of dimes. And that's what this question is asking. Is the number of dimes a function of the number of quarters? Meaning, does the number of dimes depend on the number of quarters? Write a rule that starts with D equals that you can use to determine the output D from a given input Q. If no, explain why not. Well, the fact that I can't find the number of dimes without knowing the number of quarters tells me that the number of dimes does absolutely depend on the number of quarters. So when we write this, we're going to say yes. The number of dimes does depend on the number of quarters. If you know how many quarters, then you can find out how many dimes. You can determine how many dimes. I could probably use better language here and say determine the number of equation or the number of dimes. Now, what we saw here is that we saw that the number of dimes, if we're talking strictly about the number of dimes, the number of dimes would have to be equal to the amount of money that I had minus the number of quarters that I had. But here's the trouble with this. If I'm going to just describe the number of dimes that I have to get rid of this coefficient of 1/10. And so what I would do is divide everything by 1/10. And that would give me the equation for this rule, or the function, that the number of dimes is equal to 125 cents, or excuse me, 125 cents that I'm given, minus, well, let's forget about the cents that I said there, 2 and 5/10 of Q. And this would be our equation strictly to find the number of dimes. This rule right here determines, right, the output D from a given input Q. So let's see here. Determines number of dimes. Actually, I can take that a little bit better. Determines output D from given input Q. All right, so that's what we're talking about by a rule. This rule right here tells me what my D, outcome, would be when I know the Q. So let's talk about if we have dimes now. So all of a sudden now we know that Jada has a bunch of dimes. So when we talk about this, we would say 1/10 of 25 is, plus 25 hundredths of Q, saying how many quarters, is equal to 12 5/10. I would go through the exact same process, taking 1/10 of 25, which would make this 2 5/10, plus 25 hundredths in quarters, which would give me 10. And that means that I'm talking about $10 in quarters. I would take that, What I would end up with next is 25 hundredths of quarters is equal to 10 from subtracting 2 5/10 from 12 5/10. And I would find out that my number of quarters has to be 40. I can do this again. I can do this all day. When I know the number of dimes, I can figure out the number of quarters pretty quickly, pretty easily. Oops. That's really getting squished. I'm so sorry. Let's try this again. 25 cents in quarters for a total of $9.50 means I'm going to get 30 quarters. All right. So what we can see here is we just flipped everything around. When I knew how many dimes there were, or how many quarters there were, I could figure out how many dimes. Now, when I knew how many dimes there were, I could figure out how many quarters. So is the number of quarters a function of the total number of dimes? Absolutely, for all the same reasons. If you know how many dimes, you can determine the number of quarters. So now we need to look at how can I write this where I just get all by itself Q is equal to. Well, again, going back to the first thing, if we know how much it is per quarter, then we have to take away the dimes, which means we have $12.50 minus the value of all of the dimes together. But in order to get that Q by itself, we have to divide by 25 hundredths. And then what we're left with is that the number of quarters is equal to 50 minus 4/10 of D. And what we've essentially done is taken this original equation that we had right here, which was not in slope-intercept form, not in standard form, because it's all decimal values, and we've turned it into a slope-intercept form equation. Both of these ones right here. We've turned them both into slope-intercept, but you can see that we actually switched around the outputs as we look at the two of them. So what we need to understand from this situation is that sometimes the sometimes the independent and dependent variables can't be distinguished. Sometimes either variable can be independent. And the reason we can say this is because when I didn't know the number of quarters, but I knew the number of dimes, so I knew the number of dimes, I could find the number of quarters. And then vice versa, when I knew the number of dimes, I could find the number of quarters. What this means, since it's not always the case that we have a situation like this, we need to be able to understand what it means and for having an independent variable. The cool thing about this situation is you can choose which one will be independent. In the math world, what we often find is that the first variable that's listed typically becomes the input, and the second one typically becomes the output. This is the general terms for how we decide this in the math world. Although either one of them could be independent, either one could be dependent. In this situation, it's just the most important thing is to understand, does one depend on the other? And in this situation, either situation will work. And this is how we can get a function from this. In summary, we can sometimes represent functions with equations. For example, when we're talking about the area of a circle, we find the area of a circle by multiplying pi times the radius squared, and we can write an expression or write an equation like this. Area is equal to pi times the radius squared. We can also draw a diagram that looks like this, where our input is the radius, our output is the area, and we can think of the radius as the independent variable and the output, the area, as the dependent variable, because we can simply find the area based on the radius, and the area changes as a result of the radius. The radius does not depend on the area. We would have to understand that as an independent variable, this one must come first, and it has a specific placement. And the area has a very specific placement because the area depends on the radius when we're talking about those pieces. But sometimes we get situations where we have equations where you get to choose which variable is the independent variable. For example, we know that 10 times a minus 4 times b is 120. Then we can think of a as a function of b and write a situation like this. So we can simplify by getting a by itself, adding 4b to the right side, and then dividing everything by 10 to state that, well, when I want to find the value of a, then I can plug in a value for b. I can think of a as the function of b. When I know what b is, I can find a. Likewise, I can find out the value of b when I know the value of a, so I can switch them around, and it would be totally up to me. Hope this helps for today. Remember, our key terms today are dependent and independent variable. Dependent variable refers to the output or the y coordinates. Independent variable refers to the input or the x coordinates.